March 2026 marked the closure of the Strait of Hormuz. This global energy bottleneck isolated entire economies from their primary fuel sources within hours. 21% of petroleum, 25% of LNG, and 30% of LPG transit this single bottleneck. While the U.S. relied on domestic shale and China absorbed the shock with 120-day strategic reserves, India entered the crisis with highly concentrated imports and critically thin reserves. Geographic concentration guarantees that a distant geopolitical conflict instantly becomes an unavoidable domestic crisis for any import-dependent nation. Yet the initial panic masked a strange paradox. Prices for gasoline and diesel at India's state-run pumps remained largely stable. India's massive domestic crude refining capacity insulated its transport sector. The true systemic failures bypassed the highways entirely, striking the country's cooking infrastructure and agricultural supply chains. The immediate deficit hit 330 million Indian households relying directly on LPG cylinders for daily cooking. Supply chains dried up, triggering immediate fuel rationing. Simultaneously, the crisis crippled the fertilizer sector. Without imported energy feedstocks, domestic urea and ammonia production dropped, pushing the supply shock into the food system. Insulating an economy of this scale requires executing a substitution cascade, a systematic process of shifting demand away from highly vulnerable imports and anchoring it to secure domestic resources. Ultimately, surviving an external blockade requires completely re-engineering the fundamental chemical dependencies of a nation's economy from the ground up. Look at this dashboard. LPG is the single most critical vulnerability point, operating with a 92% Hormuz exposure. Chemically, LPG is propane and butane, a tiny byproduct of refining. India's domestic refineries simply cannot scale production to meet national demand. The resulting shortfall forces India to import up to 20 million tons of LPG annually. 92% of those imports originate from Gulf suppliers, entirely dependent on the Hormuz transit route. While China directs its LPG consumption into petrochemical plants to manufacture plastics, over 83% of India's LPG is routed directly into household kitchens. Lacking an industrial buffer means the government cannot temporarily shut down factories to free up fuel during a crisis. The supply shock hits civilians immediately. This volumetric comparison illustrates the exact scale of the trap. During a sustained closure, India faces a structural shortfall of up to 11 million tons per year. Its physical rock cavern storage holds only 0.14 million tons, equating to a 1.5-day buffer. A 92% choke point exposure, 0 industrial buffer, and a 36-hour reserve capacity creates a mechanism that instantly starves 330 million kitchens. Shifting households from LPG cylinders to piped natural gas drops the exposure counter to 53%. LNG uses a diversified supply chain, drawing from the US and Australia. These alternative routes entirely bypass the Strait of Hormuz and the Bab el-Mandeb choke point, providing geographic insulation. Executing this requires laying city gas pipelines to individual homes, a feasible target for dense urban centers, but a generational infrastructure challenge for rural India. Migrating to piped natural gas successfully cuts choke point exposure nearly in half. It trades an acute import dependency for a more manageable one, but the import risk remains. Even within that manageable LNG supply chain, India suffers from a hidden, correctable infrastructure flaw at its own coastal receiving terminals. This flowchart tracks rich LNG, gas laden with heavy hydrocarbons. Fractionation separates these out. Currently, exporters strip these liquids, forcing India to pay twice. Installing domestic fractionation units captures up to 3 million tons of domestic LPG annually from gas already bypassing Hormuz. Failing to extract these liquids domestically forces the country to bleed foreign exchange while remaining artificially vulnerable to supply shocks. Resolving the remaining LNG vulnerability activates Layer 3, the fertilizer sector processing natural gas to extract hydrogen for ammonia production. Coal gasification provides the domestic workaround. Reacting high-ash coal inside a gasifier outputs syngas, a mixture of carbon monoxide and hydrogen. This domestically produced syngas replaces imported LNG in fertilizer plants, maintaining agricultural output without foreign methane. Furthermore, That same syngas can be processed into dimethyl ether, or DME. Indian regulators now permit a 20% DME blend directly into domestic LPG cylinders, requiring zero modifications to household stoves. The sheer scale of India's domestic coal reserves makes this independence mathematically possible. The country produces over 1 billion tons of coal annually. The logistical bottleneck is not a lack of raw material. The rail network is currently clogged with passenger traffic, preventing the bulk transport of coal to the necessary gasification plants. Scaling domestic coal gasification severs the final links to the Gulf. It drops the Hormuz exposure for both food security and household cooking to zero. This is the fully resolved Cascade Algorithm. Critical demand for LTG and LNG has been completely rerouted to domestic coal, renewables, and diversified crude paths. The choke point exposure counter rests at zero. Does a developing economy have the capital required to build these structural defenses? Building a 10-year strategic reserve across all fuels costs $8.3 billion. Contrast that with 1 year's LPG imports at $12.6 billion, plus $18 billion in decade-long subsidies. These subsidies distort the market, trapping households in vulnerability and suppressing the shift toward cheaper, secure alternatives. The capital required for total energy sovereignty already exists within the domestic economy. It is currently being spent to subsidize the vulnerability. A nation's exposure to global supply shocks is a choice, dictated not by geography, but by its willingness to re-engineer and finance its own systemic resilience.